Ammonia, when not covered, cools down to below its boiling point. Temperatures down to minus 45 degrees have been measured in this bucket. The usual butyl gloves become brittle when lowered into the cold ammonia and break under movement. The low insulation gloves from TST gives adequate protection to the hand against the low temperatures and remains flexible. The bottle is flushed with liquid ammonia. Now it contains ammonia vapor. When the ammonia vapor becomes in contact with water, it dissolves. It causes a collapse of the gas volume. The water is drawn into the bottle instantly. This can be very dangerous should water be drawn into an ammonia plant. The reaction of liquid ammonia in water is very violent. If liquid ammonia is added to water, the mixture will boil because of the higher temperature of the water and the hydration heat, which leads to a more powerful reaction. If water is added to liquid ammonia, the reaction is much more violent. The mixture in the bucket heats up due to the chemical reaction. Such a reaction must be avoided under all circumstances. The liquid ammonia boils on the ground and evaporates. Should this occur in a room, the air will become highly contaminated and fatal concentrations of ammonia can occur very quickly. High concentrations of ammonia are toxic to inhale. Ammonia also attacks the skin, especially the mucous membrane. Eyes must be flushed immediately in case of contamination. Ammonia can get very cold. Temperatures down to minus 70 degrees Celsius have been measured in the aerosol. Ammonia can cause skin blisters, which look like blisters caused by burns. Exposed areas of skin must be washed with plenty of lukewarm water. The white aerosol cloud is very cold. It can cool down to minus 77 degrees Celsius. The majority of man-made fabrics become brittle and break. The TST suit comprises a white sleeve which serves as a chemical barrier. It is resistant and flexible down to minus 80 degrees Celsius, and temperatures up to 1000 degrees Celsius can be withstood for a short period. The red insulation suit worn underneath protects the skin against extreme temperatures in the same way as a firefighting suit. Air and ammonia gas mixtures are explosive. A deflagration occurs, however, the energy released is not as high as the energy released by an explosion with propane gas in air. The TST suit is resistant to this temperature, which has been proven by tests. If the ammonia is ignited, it will not continue to burn. It can only be kept burning with a support flame. Certain metals also dissolve in ammonia or in mixtures of ammonia and water. Due to the high evaporation heat, recondensation of the ammonia in the aerosol is possible, and it becomes liquid ammonia. The drops of ammonia in the aerosol are recondensed in an insulated flexible plastic tube to liquid ammonia, which can be conveyed to the tray. Sealed off in the insulated plastic tray, the liquid ammonia remains stable, hardly boiling off since it has cooled down well below its boiling point. Working with TST protective clothing is trained under realistic conditions at Survival Training Center in Esbjerg. An ammonia cooling plant is simulated in a container. The task is to rescue a person and close the leakages. The concentration of ammonia is 3% in this container, an absolutely fatal concentration. Wearing the safety suit, work can be performed safely as long as the safety regulations are observed. Course instructor monitors the work through a screen. The container can be ventilated immediately in case of problems. Several training courses are necessary every year to ensure safe working under difficult conditions, such as working from ladders. It is difficult to work in the dark. The rescue team can only work in the light of a torch. The entire plant is monitored with infrared, given the opportunity to follow the work of the rescue team continuously.